Bloomington Animal Shelter adoption case has multiple objectives to understand and improve adoption dynamics. First, the study examines breed adoption rates over time to understand community preferences. Second, the analysis examines how demographic characteristics like age, sex, and adoption location affect species adoption rates. This goal includes sub-objectives that answer the following question. Are there specific breed trends in adoption over time? Second, how do demographic factors such as age, sex, location of adoption influence adoption rates for different breeds at the Bloomington Animal Shelter? Third, what is the average length of stay for animals at the shelter before being adopted, and how does it vary by breed and age? Assessment of situation. The Bloomington Animal Shelter adoption case study shows the complexity of demographic considerations, adoption preferences, and operational efficiencies in shelter animal outcomes. Data on animals' average shelter stays and the variation by breed and age is vital for improving shelter operation and animal welfare. The initial data mining goal is breed trend analysis to determine breed adoption rates over time. This objective uses time series analysis to understand adopters' breed preferences and direct resource distribution and outreach to promote disadvantaged breeds and reduce overpopulation. This target uses association rule mining and regression analysis to find connections between demographic characteristics and adoption outcomes to customize adoption programs for specific population. Data mining objectives support the case study's goal and give vital insight to inform decision and improve results.
Production of project plan. The production of our project plan for our data mining initiative is a comprehensive process aimed at ensuring the successful execution of every stage of the project. Each component of the plan, from the initial selection of the dataset to the final preparation for presentation, is meticulously detailed with sufficient time allocation and careful consideration. Our project plan is designed to deliver successful outcomes within the allocated time frame by leveraging a combination of careful planning, rigorous analysis, strategic resource management. We aim to meet stakeholders' expectations and provide a actionable insights for informed decision making.
Chapter 2, Data Understanding. So, for collecting our initial data, in this study, researchers used the adoptions by breed and date dataset from Kaggle because it is well known for having diverse data that's good for machine learning projects. Kaggle makes it easy to find datasets, which helps us speed up data science work. For describing the dataset in question includes detailed information about the outcomes of animals adopted from the Bloomington Animal Shelter, totaling about 10,300 rows of data. This dataset has 22 columns. For exploring the dataset in question serves as a comprehensive record of animals adopted from the Bloomington Animal Shelter, capturing data during the transition from the old Animal Shelter Net software to the new Shelter Manager system. It demonstrates the shelter's dedication to maintaining crucial data despite technological changes. With details like intake dates and unique identifiers, it illustrates animals' journeys through the shelter and provides insights into adoption trends. By recording movements and outcomes, it reflects shifts in shelter practices and aids research on adoption patterns while emphasizing the commitment to animal care and advocacy. Uh, for our feature selection, this analysis section explores the connections within the dataset to improve its accuracy. Researchers aim to refine the dataset by examining correlations between different data points through processes like data cleansing, pre-processing, and visualization. As you can see in our figure, the correlation heat map highlights in red which can be used for our project, while blue shades indicate less relevance that is not useful for our project. Distribution graphs in this figure, as you can see in the figure on the right, reveal central tendency, variability, and data distribution shape, aiding in outlier detection and comprehension. For verifying data quality, to answer our business questions, we focus on specific data attributes. These include adoption, date or time, demographic details like age, sex, and location of the animal, and animal breed specifics. Columns like movement date, animal age, sex name, location, species name, intake date, and breed name are essential for our analysis. Other columns unrelated to these questions are removed from the dataset. So here's the table for chosen columns and its data type.
Let's get into chapter 3, data preparation. So for 3.1 data selection, in this phase of our analysis, we carefully select specific columns for the adoptions by breed and data. So dataset to focus our research on understanding adoption trends, demographic influences on adoption rates, and the typical duration of stay before an animal is adopted. So this selective method ensures that we only work with the most relevant data, improving the accuracy and relevance of our results. So we detail the columns here in this table 3.1, retained for our research and explain their significance to the project's objective. Moving forward to 3.2, clean data. So during the transition to the data cleaning phase, the main objective is to refine and optimize the data set to ensure accurate analysis. So here in figure 3.2, here's the complete data set prior to selection and cleaning. This involves a sequence of procedures designed to fix discrepancies, rectify mistakes, and eliminate extraneous or repetitive data. So the procedure is essential for ensuring the integrity of our findings since it directly impacts the quality and dependability of the data. Here in figure 3.3, here's our selected columns for detailed analysis. Then for figure 3.4 is our initial data exploration for normalization potential. So here we used Google Colab to check if there is and understand the data set if there is any discrepancies in our selected columns for detailed analysis. And as you can see that the animal age stated 9 years and 9 years 2 months. So these two we used Python scikit-learn libraries, specifically the standard scalar module, to normalize our data. So this tool normalizes the animal age column by changing it to a scale with a mean of 0 and a standard deviation of 1. So using raw data directly for analysis can lead to misleading results due to scale differences among variables. So to solve this issue, we utilized Python scikit-learn library, as I've said earlier, specifically the standard scalar module to normalize our data. So normalizing the data, each feature contributes equally to the research, preventing any one feature from dominating due to its scale. So these allow for more accurate and informative statistical analysis and visualization. So in this figure 3.4, this is the normalized data using scikit-learn in Google Colab. So the animal age here have already changed to a scale with a mean of 0 and standard deviation of 1. And the figure 3.4 normalized data in CSV file. Moving on to data construction and generated records. In the development of our comprehensive dataset, the integration and construction of data played a pivotal role. Initially, we sourced our data from Kaggle, which included diverse records from animal shelter management systems and veterinary records. So the collection provided a wide range of data points, ranging from intake particulars to health and adoption results. So before integration, a thorough cleaning procedure was necessary to rectify anomalies or remove any corrupted or error entries, thereby guaranteeing the data's reliability. So the cleansed data were subsequently merged into consolidated structured repository, an important phase in creating a cohesive data set that facilitates comprehensive analysis and well-informed in decision making. So in addition, the researchers created new records to improve the comprehensiveness of the research analysis. Recalculations of animals' ages were conducted to enhance comprehension of age dispersion during the adoption process. So this improvement was a component of the wider process of making the dataset more consistent and uniform, specifically designed to prepare it for thorough analysis. So this enables the use of advanced analytical techniques without any distortions caused by differences in data scale or formats.
Data formatting. Data formatting is a crucial step in our data preparation process, ensuring alignment with our modeling techniques. This systematic approach guarantees that only one most pertinent data is utilized, enhancing the precision and significance of our conclusion. During the data cleaning, our focus is on optimizing the data set for precise analysis. integrating and building data from various sources, including Kaggle, involve comprehensive cleaning to eliminate anomalies and ensure data reliability. The objective of these efforts is to prepare the data sets for sophisticated analytical methods while maintaining consistency and preventing distortions from data format or scale variation. Modeling technique. In this phase, our aim is to develop a robust model to understand animals' typical stay duration at the Bloomington Animal Shelter before being adopted. Using linear regression, we'll focus on key variables like breeds and age to identify factors influencing shelter. Through tailored interventions informed by model findings such as shortening stay duration, we aim to streamline the adoption process, benefiting both adoptable animals and prospective adopters.
For the test design generation, we utilize linear regression as the primary modeling technique to improve shelter operations and comprehend adoption dynamics. This method anticipates results by analyzing and predicting the relationships between quantitative factors. Using exploratory data mining techniques, including regression analysis and association rule mining, allow the shelter to efficiently customize its programs by looking at the impact of demographic characteristics on adoption rate. For this part, the visualization show how age, gender, and location influence adoption rates at the Bloomington Animal Shelter. It also explores the correlation between predicted and actual length stays for animals. The 91.94% adoption rate reflects the shelter's effectiveness in managing animal population. By analyzing age, gender, and location, the code predicts animals' shelter stay duration before adoption. And for this visualization, it also shows the adoption trend over time, revealing breed popularity. A linear regression modeling technique predicts shelter stays using breed and age, enhancing shelter's operation. This study provides insights for Bloomington Animal Shelter's adoption plan. Proceeding next to the model assessment, the scatter plot illustrates a predictive model for forecasting animal shelter stays. The model's accuracy is assessed by the clustering of blue dots around the red line, with tighter clustering indicating more precise predictions. Additional metrics such as mean square error, R squared, and mean absolute error further evaluate the model's efficacy in forecasting animal shelter stays. Then lastly, the graph shows the correlation between animals' age, breed groups, and length of stay at the animal shelter. It also uses a scatter plot to identify patterns and categorize animals into similar breeds for analysis. This approach provides a comprehensive understanding for the impact of age and breed on stay duration. The average length of stay by breed group was also shown.
Evaluation. Results evaluation. We use linear regression as primary modeling techniques to predict the length of stay for animal at the shelter. We use scatter plot visualization and metric like mean square error, R squared, and mean absolute error to analyze the relationship between age, breed group, and duration of stay. The results showed no specific breed trends, with domestic cats and other breeds being majority. Examining parameters such as age, gender, and location has an adoption rate results of 91.94%. The average length of stay at the shelter adoption was 34.61 days. Review of process. Researchers use the adoption review dataset to analyze animal adoption pattern between 2017 and 2020. We applied data mining algorithms to identify trends and patterns in adoption behavior. The model accurately captured adoption patterns and demographic variables and typical stay lengths. This approach provides insight into impact of breed groups and age on an animal stay. Determination of next steps. The study reveals new variable affecting animal stays at the Bloomington Animal Shelter. The model could be improved by incorporating more variables and examining trends from 2017 to 2020. Age and breed are key factors, but other factors like seasonal changes in animal health and marketing effectiveness could also impact stays. Adjustment to shelter adoption procedures, such as marketing campaigns or targeted programs, could be implemented based on the findings. This will ensure every animal finds a loving home, befitting both animals and adopters. And that is all. Thank you.